To go from one term to the next term in a geometric sequence, we multiply by a common ratio. This question says find the nth term of the geometric sequence. Let's find the common ratio. So what do you multiply 72 by to get negative 36? Or negative 36 by to get 18? To find that, we can just do negative 36 divided by 72. So it's minus a half. To get from one term to the next term, the term-to-term rule is multiplied by minus a half. So we can say the common ratio is minus a half. The nth term of a geometric sequence, we'll call it un, is a times r to the power of n minus 1. So it's the first term, a, times the common ratio to the power of n minus 1. So in this case, un is a, which is 72, times r, which is minus a half, to the power of n minus 1. That's our nth term, so we could use that to find any term in the sequence. So if we made n 4, we should get negative 9. So 72 times minus a half to the power of 4 take away 1 is negative 9. Okay, one for you to try. Pause the video, give it a go. So this time the common ratio, how would you get from 3 to 6? 6 to 12 and 12 to 24. We're multiplying by 2 each time. So the common ratio is 2. The first term is 3. So the nth term is a times r to the power of n minus 1. 3 times 2 to the power of n minus 1. The second term of a geometric sequence is 40, and the fourth term is 250. Find the two possible values of the first term and the common ratio. So the second term, u2, is 40, and the fourth term, u4, is 250. And our general rule is un is ar to the power of n minus 1. So the second term is 40, and that's a r to the power of 2 minus 1, which is 1. So 40 is ar, and the fourth term, 250, is a r to the power of n minus 1. 4 take away 1 is 3. So we've got simultaneous equations here. And to solve them, we're going to divide. So the top one divided by the bottom one. So 250 over 40 is 25 over 4. A over a cancels. R cubed over r is r squared. And so r is the square root, the positive or negative square root. So it's plus or minus 2.5. So r is either plus 2.5, so we're either multiplying by 2.5 each time, or we're multiplying by negative 2.5 each time. What's the two possible values of the first term? What could a be? So let's use 40 equals ar. If r is 2.5, it'd be 40 over 2.5. If a is negative 2.5, it'd be 40 over negative 2.5. So 40 over 2.5 is 16. So a could be 16, or a could be negative 16. One for you to try. Give it a go. So we've got u3 and u4. Find the first term and the common ratio. So we can find the common ratio by doing u4 divided by u3. What do you times 54 by to get negative 81? And that is minus 3 over 2. So that's the common ratio. Let's use our general rule. So un is ar to the power of n minus 1. And for the third term, 54 is a times minus 3 over 2, which is r, to the power of n minus 1. 3 minus 1 is 2. So we're squaring it. So 54 is 9 over 4 times a. So 54 divided by 9 over 4 is 24. So a is 24. So we've got r is negative 3 over 2 and a is 24. For a geometric sequence, u2 is 6, u5 is 162. Find the smallest value of k for which the kth term exceeds 100,000. So again, the general rule, un is ar to the power of n minus 1. So for the second term, 6 is ar, and the fifth term, 162, is ar to the power of 4. Let's do the top one over the bottom one. 162 over 6 is 27. And that is r cubed. The a's cancel. R to the power of 4 divided by r is r cubed. And then cube root, which makes r3. So now we know the common ratio. And we can find the first term. 6 is a times r. So a must be 2. So we've got the first term and the common ratio. The smallest value for which the kth term exceeds 100,000. So exceeds 100,000 means it's bigger than. And it's a times r to the power of, well, k minus 1 in this case. So that's half both sides. And so if we want to find what k would be, for them to be equal, we're going to use a log. So let's log both sides. Let's say log 50,000. And we'll have log, so k minus 1, log 3. So the k minus 1 will jump to the front. So k minus 1 is bigger than log 50,000 over log 3. Log 50,000 over log 3 is 9.8 and so on. So 9.8. K minus 1 is bigger than 9.8. So add 1 to both sides. K has to be bigger than 10.8. So K will have to be 11. 11 is the smallest value of K for which the kth term exceeds 100,000. And we can of course check. So if we have A, which is 2, times R, which is 3, to the power of n minus 1 or k minus 1. So k minus 1 is 10, 11 minus 1. We can see it's above 100,000. If it was 9, it's below. One for you to try. Give it a go. A geometric sequence has first term 2, a equals 2, and the fourth term is 54. So 54 is a, which is 2, times r to the power of n minus 1. 4 minus 1 is 3. So r cubed is 27 again. R is 3. So a is 2, r is 3. That's exactly the same as the last one. And the smallest value of k for which the k term exceeds 50,000. So this is the same question, but we've got 50,000 and it exceeds it, so it's bigger than. And it's a, which is 2, times r, which is 3, to the power of n minus 1. So half both sides, and then log both sides. So n minus 1 jumps to the front. We've got log 3. Divide both sides by log 3. So log 25,000 over log 3 is 9.2. So add 1 to both sides. So n is bigger than 10.2. So n, or k even, is 11 again. And we can check again. So it was at 39,000 for the 10th term, and the 11th term 118,098. So k is 11 again.